Welcome to our lesson on arithmetic progressions. An arithmetic progression, often abbreviated as AP, is a sequence of numbers where the difference between consecutive terms is constant. This constant difference is called the common difference, typically denoted by the letter D. Let's establish some key terminology. In an arithmetic progression, we call the first term I and the common difference D. The common difference can be found by subtracting any term from the term that follows it. For example, if we have the terms 2, 5, 8, 11, and so on, the common difference would be 3, since each term increases by 3. Now, let's discuss how to find any term in an arithmetic progression. The formula for the nth term of an arithmetic progression is a sub n equals a plus n minus 1 times d. This formula tells us that to find the nth term, we start with the first term and then add the common difference d exactly n 1 times. Another important aspect of arithmetic progressions is finding the sum of the first n terms. The formula for this sum is s sub n equals n divided by 2 times 2a plus n minus 1 d. Alternatively, we can write this as s sub n equals n divided by 2 times first term plus last term. Let's practice with some questions. Question 1. Find the 20th term of the arithmetic progression 3, 7, 11, 15. To solve this, we first need to identify the first term and the common difference d. Here, the first term equals 3. To find d, we can subtract any term from the next one. 7 minus 3 equals 4, or 11 minus 7 equals 4. So d equals 4. Now we can use the formula for the nth term. A sub n equals a plus n minus 1 times d, substituting our values. A sub 20 equals 3 plus 20 minus 1 times 4 a sub 20 equals 3 plus 19 times 4 a sub 20 equals 3 plus 76 a sub 20 equals 79. Therefore, the 20th term of the given arithmetic progression is 79. Question 2. Find the first term of an arithmetic progression whose common difference is 4, and the sum of the first 10 terms is 160. Let's denote the first term as and use the sum formula. S sub n equals n over 2 times 2a plus n minus 1 d, substituting what we know. N equals 10, d equals 4, and s sub 10 equals 160. 160 equals 10 over 2 times 2a plus 10 minus 1 times 4. 160 equals 5 times 2a plus 36. 160 equals 5 times 2a plus 5 times 36. 160 equals 10a plus 180. 160 minus 180 equals 10a minus 20 equals 10a equals minus 2. Therefore, the first term of the given arithmetic progression is minus 2. Question 3. How many terms of the arithmetic progression 9, 17, 25, 33 must be taken so that their sum is 636? Let's first identify the key values. The first term equals 9, and the common difference d equals 17 minus 9, which is 8. Using the sum formula, s sub n equals n over 2 times 2a plus n minus 1 d, substituting our values. 636 equals n over 2 times 9 plus n minus 1 times 8. 636 equals n over 2 times 18 plus 8 n minus 8. 636 equals n over 2 times 10 plus 8 n. 636 equals n times 5 plus 4 n. 636 equals 5n plus 4n squared, rearranging to standard form. 4n squared plus 5n minus 636 equals 0. Using the quadratic formula, we get n equals 12, or n equals minus 13.25. Since n represents the number of terms, it must be positive, so n equals 12. Therefore, we need to take 12 terms of the given arithmetic progression to get a sum of 636. Question 4. Insert two arithmetic means between 4 and 16. We need to create an arithmetic progression with 4 as the first term, 16 as the last term, and 2 numbers in between. So we have a total of 4 terms. Let's find the common difference first. We know that it equals 4, n equals 4, and a sub n equals 16. Using the formula a sub n equals a plus n minus 1 times d, 16 equals 4 plus 4 minus 1 times d. 16 equals 4 plus 3d. 3d equals 12, d equals 4. Now we can find the two arithmetic means. A sub 2 equals a plus d equals 4 plus 4 equals 8. A sub 3 equals a plus 2d equals 4 plus 2 times 4 equals 12. Therefore, the two arithmetic means between 4 and 16 are 8 and 12. Question 5. The first term of an AP is 5, the last term is 45, and the sum of all terms is 400. Find the number of terms and the common difference. Let's denote the number of terms as n and the common difference as d. We have the following information. A equals 5, a sub n equals 45, and s sub n equals 400. Using the formula a sub n equals a plus n minus 1 d, we get 45 equals 5 plus n minus 1 d. 40 equals n minus 1 d. We also know the sum formula. S sub n equals n over 2 times a plus a sub n. From this, we can write 400 equals n over 2 times 5 plus 45. 400 equals 25 and n equals 16. Now that we have n, we can find d. 40 equals 16 minus 1, d. 40 equals 15 d. d equals 8 over 3. Since d should be the difference between consecutive terms, and we need a whole number for n, we check our solution. With n equals 16 and d equals 8 over 3, the list term a sub n would be a plus n minus 1, d equals 5 plus 15 times 8 over 3 equals 5 plus 40 equals 45. The sum would be n over 2 times. A plus a sub n equals 16 over 2 times. 5 plus 45 equals 8 times 50 equals 400. Therefore, the number of terms is 16, and the common difference is 8 over 3. To summarize what we've learned about arithmetic progressions. 1. An arithmetic progression is a sequence where the difference between consecutive terms is constant. 2. The formula for the nth term is a sub n equals a plus n minus 1 d. 3. The sum of the first n terms is s sub n equals n over 2 times 2a plus n minus 1 d, or equivalently, s sub n equals n over 2 times first term plus last term. Practice these concepts by working on more problems. The key to mastering arithmetic progressions is understanding how to apply these formulas to different scenarios.